Okay, so this is Algebra 2, Chapter 6, and this is our quick review, and this is really Chapter 6A. So just going to focus here on the beginning part of Chapter 6 and dealing basically with graphing quadratics, all right? So front part of 6, and basically we're going to deal with graphing quadratics. All right, first off, we've got to have down our classification system, and look, this isn't really hard. First off, you need to determine the degree. If you figure out the degree, you'll figure out if it's linear, quadratic, or polynomial. So the degree is the degree of the highest degree term. So if you look here at this example, I got to move that cursor is right in my way there. Sorry about that. But if you look at the degree, this is x, the variables to the first power. So this is first degree. And because it's first degree, it's linear. All right, basically anything first degree is going to be linear. Okay, that's the idea, and that's the concept as you go down. So let me go to the next one. Again, you can see that the variables, both of them, are to the first power. This is first degree, and therefore it's linear. All right, I'm going to continue down. Notice here, we've got a variable to the second power, it's a second degree, and this is quadratic. So second degree is quadratic. Next example, same thing. Remember that exponent is going to apply to that variable, and so this is a variable squared, second degree, and it is quadratic. This example, remember the degree is the degree of the highest degree term. So this is a third degree. And remember, any degree greater than or equal to third is a polynomial. So our last example, we have a fifth degree. But again, fifth degree is greater than or equal to third degree, and therefore it's a polynomial. So the first thing you got to determine is what is the degree, and the degree will tell you whether it's linear, quadratic, or polynomial. Now, the second aspect is how many different variables. All right, the first example here has just one, right? If there's just one kind of variable, then it's an equation. One kind of variable, it's an equation, all right? So I'm going to go through. Let's just go one by one. So you look at the second one, you have x's and y's. You have two different variables. When there are two different variables, then it is a function. And again, this is a generality. Remember, you have to really technically look at the vertical line test, but the parabolas we're doing and such are going to end up being functions for now. So it's just generality. Okay, look at the second one. Again, how many different variables do you have? Just one, they're x's, and so it's an equation. Next example, what do you have? Two different variables. You got an x and a y, therefore it's going to be a function. Third example, just x's, just one kind of variable. It's an equation. And the last one, again, you look, you got x's, you got y's, you got two different variables, and it is a function. Now, that's not hard, okay? That's not hard. That's doable. And so you need to be able to classify. You'll see some of that on your quiz and then also on your test, all right? Be careful of set things. Let me just real quickly remind you of a few things. Y equals mx plus b. That's slope-intercept form of a linear equation, but technically that's a function. Two different variables, x and y to the first power. Ax plus by equals c. That's a standard form of a linear function, so be careful there. Ax squared plus bx equals c. That would be a quadratic equation, right? Et cetera, et cetera. So be careful with some special forms. Okay. You got to be able to recognize max and mins, the coordinates of the max or min point, line of symmetry, relative width, okay? And so here's our generality, y equals a to the x. And this is the most basic of the forms. I'll show you all the forms in a moment here, but this is the most basic. So, let's suppose we had just simply y equals x squared. All right, first off, what's the value of a? And hopefully you understand that this is a 1. So you got a positive 1. So this is a min, right? Positive a is a min. Negative a is a max. What are the coordinates of our min point? And they are 0, 0. And you have to remember that on this kind. Now, I could write the full form. I'll show you that in a little bit. But it's a min. The min point's at 0, 0. Line of symmetry. X equals always the x coordinate. If you get your vertex correct, you'll get your line of symmetry correct. All right, and is this thing relatively wide or relatively narrow? Well, in my estimation, I say anything greater than or equal to 1 we consider to be relatively wide or flatter. Okay? How do you graph this? You always want to graph the vertex first. 0, 0, right? So I'm going to graph that 0, 0 point. Let me get rid of this arrow. Okay, next, you go to an XY chart. And by the way, don't forget your line of symmetry. It's going to allow us to save time. Okay, I'm at 0, 0, so I'm going to use 1 for an x. Again, I'm going into my original function. 1 squared is 1. So I have a point at 1, 1, and I have another point at negative 1, 1 on the other side of the line of symmetry. I'll do a 2. Again, I'm putting in 2 for the x. 2 squared is 4. And so I have the point 2, 4, and that's really enough for me to draw my parabola. And again, we're calling this relatively wide. The book uses the term flatter or steeper. Okay, so relatively flat. Okay, second scenario. Now we can bump it up a little and now add a k value. And remember, k is the vertical shift. We can now take this basic function and we can shift it vertically. All right, so for practice sake, I have this one. Now, notice the value of a. It is positive, so we know we have a min. Whoops. Get this back where I want it. So we know this is a min. And what are the coordinates of the min point? 0, negative 4. 0k. All right. Again, line of symmetry. X equals 0. Is this thing relatively wide or relatively narrow? This is relatively narrow, and I messed up that first one, didn't I? Sometimes you catch yourself. This is relatively narrow. All right, greater than or equal to 1 narrow, less than or equal to 1 wide. All right, be careful. I'm glad I caught myself. Hopefully you'll do that as well when you're doing it. So greater than or equal to 1 we'll consider relatively narrow. Okay, and you'll see as I graph this how that will play out. Let me go ahead and do this one in green. So again, how would you graph this? First thing you want to do is you want to graph the vertex. So 0, negative 4. Again, our line of symmetry is x equals 0, so we are in line with the other line of symmetry. I'm going to come over here and do an XY chart. Okay, so I'm already at 0, so I will use 1, putting in 1 for the x value. 1 squared is 1 times 2 is 2. 2 minus 4 is a negative 2. So I have the point 1, negative 2. And I go on the other line of symmetry and the point negative 1, negative 2. I'll do 2. 2 squared is 4. 4 times 2 is 8. 8 minus 4 is 4, and I have the point 2, 4. That's probably enough. You can see how this parabola is more narrow than the first because, again, the a value has increased. It's gotten bigger than 1. All right, so we're more narrow, and up it goes. Okay, third scenario here, and now we get the full-fledged formula of graphing form y equals a times quantity x minus h quantity squared plus k. Now, by the way, if I asked you, if I gave you this and said, what is this? You would say this is a linear function. I'm sorry, a quadratic function, right? It's quadratic because it's squared, And it's a function because there are y and x variables. Okay, so let's do an example here of this one. Y equals 1/2 the quantity x plus 2 quantity squared plus 1. We look at our a value, and that determines that, again, we have a min, correct? Because the a is positive. Positive a is a min, negative a is a max. What are the coordinates of our midpoint? All right, be careful. This is negative 2, 1. Again, in the formula, this is a minus, so therefore it must have been minus a minus 2 to have that plus 2. What's the line of symmetry? X equals negative 2. So remember, this is our starting point. I'll graph this one in black. So we're a min at negative 2, 1, right here. In this case, our line of symmetry is right up there. I now want to do an XY chart. And please note where I'm at. I'm already at negative 2. Right? I'm right here at my vertex at negative 2. Therefore, that's going to tell me, hey, I'm going to move to the right. Now I can go 1. I'll do 1 here. Normally I would do 2 with a half. Right? Look at our a value is a half. But let me do 1 because you might. 1 plus 2, I'm right here, right? 1 plus 2 is 3. 3 squared is 9. 9 times a half is 9/2, or 4.5. And 1 more would be 5.5. Okay. We're all the way up there. It's pretty quick. All right, let me check that one more time. Oh, so no wonder I'm supposed to be doing negative 1. Boy, this is getting goofed up today, isn't it? Oh well, such is life. It's early in the morning. This is Monday morning. We had our cantata last night, up late, so such is life. All right, we'll get there. Let's put a negative 1 in. That's what I wanted to do. So negative 1 plus 2 is a 1. 1 squared is 1. 1 times half is a half. And a half plus 1 is 1.5, much better. And so now at negative 1, we are at 1.5. You can see already we're quite a bit wider. Let's go to 0. 0 plus 2, I'm looking right here, is 2. 2 squared is 4. 4 times a half is 2. 2 and 1 is 3. So at 0, we're at 3. 2 to the right of my line of symmetry. I'll go 2 to the left of my line of symmetry. I'll do 1 more point. And now let's do that 1, and I already know it's 5.5, right? So 1 is 5.5. Right there, and that is 3 to the right of my line of symmetry. Go 3 to the left, and there is that parabola. And notice it is the widest of the parabolas, because again our a value is absolute value of a is less than 1, and so you get wider. Okay, so you got to take care of the 3 forms. Now let's go back to the original right here. If I were going to write the y equals x squared in the graphing form, it would be y equals 1 times the quantity x minus 0 quantity squared plus 0. But what ends up happening is those zeros, we don't want to leave them there, and we simplify down to this. You look at the second form here with just a vertical shift, and again, this, if we were going to put it in full-fledged form, it would be x minus 0 quantity squared minus 4. And again, you can see the h is 0 and the k is negative 4. So what ends up happening is we have more simplified forms. So here's the key. Y equals a times quantity x minus h quantity squared plus k. Here's one form a little bit more simplified. The horizontal shift is 0. We just have a vertical shift. And then you go over to here and we have no horizontal shift, no vertical shift. And so that's the most basic of the shapes. All right, let's get to completing the square. So to complete the square, if you remember, you want to group your variable terms. I want to now factor out, I got to get this squared term to be just x squared. So I'm going to factor out this negative 2. And when I do, I get x squared minus 4x. I still have my negative 3. Okay, so remember what we're going to do now. We're going to take the b value. We're going to divide it by 2. And then we're going to square it. So 4 divided by 2 is 2. 2 squared is 4. And so we put a plus 4 inside. What did we actually add to the right-hand side of the equation? A negative 8. So to keep things balanced, I have to add a positive 8 outside. Let's finish completing the square. Y equals negative 2. Need a parentheses. Square root of the front goes in the front. Sine of the middle. Square root of the last goes last. So we have x minus 2. Remember, that's quantity squared plus 5. So if we were asked to graph this, we're going to say to ourselves, this is a max because of the negative. By the way, it's relatively narrow, greater than or equal to 1, or steeper. Max coordinates are 2, 5. How do you graph? Start with the max coordinates at 2, 5. Here's my line of symmetry, right? XY chart. All right, now again, I'm at 2 already, so I'm going to go 3, right? So look over here, put 3 in, right? 3 minus 2 is 1. 1 squared is 1. 1 times negative 2 is negative 2. Negative 2 plus 5 is 3, and I have the point 3, 3. I'll go 1 to the left of the line of symmetry, put my other point. Let's go ahead and do 4. Again, putting 4 in. 4 minus 2 is 2. 2 squared is 4. 4 times negative 2 is negative 8. Negative 8 plus 5 is a negative 3. So we have the point 4, negative 3. 2 to the right of the line of symmetry, 2 to the left, and there's our parabola. And I'm ready to roll. Now, by the way, again, this is the max point because it's the maximum value of the parabola. Okay. Maxes go down, mins go up. Don't forget also a couple aspects. Here's the y-intercept. X-intercepts are here and here. Now you'd have to solve them mathematically by setting the y value equal to 0 and solving. Okay? We can do that. We've done that before. If we talk about domain and range, the domain is all the real numbers because this thing goes forever to the left and forever to the right. Now it's going down quicker than it's going left or right, but it has forever to go left and right. What about the range? What's the value of the range? Well, it's values of y less than or equal to 5, right? You have that max point. If you went interval form, remember you always go to the low value first, negative infinity, comma, 5, bracket, if you're going to give that in interval form. Okay, don't forget domain and range, x-intercepts, y-intercepts of our functions. Okay, last thing, couple inequalities I'll do real fast. All right, if you look here, this is the second scenario, right? We have a vertical shift, but no horizontal shift. Is this a max or min? It is a min. What are the min coordinates? 0, negative 3. It's going to plot that first. XY chart, let's use 1. 1 squared is 1. 1 minus 3 is a negative 2. I have the point 1, negative 2. Go to the other side of my line of symmetry. Okay, let's do the point 2. 2 squared is 4. 4 and 3 is 1. I've got the point 2, 1. Other side of the line of symmetry. And I guess I'll go one more. 3. 3 squared is 9. 9 minus 3 is 5. So I have 3, 5. And I'm 3 that way, and I'm 3 that way. Now, remember, less than. That means a dotted line. And remember, we also have to shade. Inequalities, you shade. Where are values less than? Under here. So really anywhere outside the parabola. And we're shading all this. Okay? Now, very quickly, what if this would have been a greater than? Then you'd have been shading in here, right? Follow? That would be the only difference. Okay, so look at the second example. So again, we look at this and say, oh, this is a max, and the coordinates of the max are negative 1, 4. Line of symmetry, x equal negative 1. So we're going to go negative 1, 4. right there. And tell you what, let's do a greater than or equal to. All right, so negative 1, 4. We plot that point, XY chart. I'm already at negative 1. Let's do 0. 0 plus 1 is 1. 1 squared is 1. But you got negative in front, so negative 1 and 4 is 3. So you get 0.13. Other side of the line of symmetry. Let's go 1. 1 and 1 is 2. 2 squared is 4. Negative 4 plus 4 is 0. 1, 0. Other side of the line of symmetry. And we'll go one more. We'll go 2. 2 and 1 is 3. 3 squared is 9. Negative 9. And 4 is a negative 5. 2, negative 5. Right there. And right there. Now this time I want a solid line, because it's greater than or equal to, like that. And again, where are the greater than values? They're above, and above is actually everything outside. So we would shade everything outside. Now, by the way, if this would have been a less than or equal to, everything would look the same except the shading would be inside. Okay? Parabolas. All right, that's the quick review. There are some other things in the chapter. Make sure you review your notes, and hopefully you'll have a great test. Have a good night.